Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 328. Ooh, oops. Difference between maximum and minimum price sum. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. And spoiler alert, I think there's a very wrong answer that is getting accepted by Leetcode. So I think there are a lot of people is going to fail this one, and this is also why I took half an hour on this one. But yeah, hope that kind of draws your interest. I'll show you what I expect a lot of people to get. And the thing is that it's very easy and alluring to do. Yeah. But basically, the idea here is that, let me bring up some joy real quick. And I actually kind of touched upon this in a previous video. But I have so many videos, so if you haven't seen it, it is what it is, right? But yeah, so let's say you have this tree, right? The idea here is that you just do a recursion on each node, right? The idea here is that, okay, let me making sure that is showing. Okay, basically each edge can be cached only one direction, right? So if you just do a naive thing, and then basically for each node, we'll start at this node, and then now this node we could go, do a depth of search on it, but a lot of these things will be cached, right? Because if you amortize it, then each node, each edge will be visited once and then cached in the forward. So then you could say that each edge will be linear time, linear space, even though you do a lot of depth first search. So again, you might have remember the spoiler alert why this is wrong, but this is a solution that I think a lot of people have gotten. Maybe not. I don't know. I'm still recording while the contest is going live. But this is, to be honest, the first solution that I kind of implemented. It came to my mind, but I was like, no, this is not right. So I just didn't implement it. In fact, I only implemented this after the contest, after I submitted correctly. And I was like, oh, let me just see if this would work. And actually, this gets accepted, but I will tell you why it doesn't work. But yeah, basically the idea is that, okay, for let me actually even check real quick. I'm curious how long this takes. And you can see that I put in a test case that time limit exceeded, even though it's accepted. So it takes about the same time as my actual AC, but it is not right. So yeah. So this is just basically what I said. I don't want to dwell too much into it. This actually comes into play a few times, but basically you do that for search. Each edge gets cached, so it's over one is what they want you to think. But using that faulty analysis that I just did is going to be linear time, linear space. You basically visit each edge once, right? And then it gets cached, but it doesn't work. So I deleted it, but so basically here I construct a test case where it doesn't work, and basically it's just a star graph of 100,000, right? Why doesn't this work? Let me bring back the drawing pad again. So this doesn't work because if you have a star graph that is like this, okay, whatever, right? So basically, let's say you do a recursion starting from here. Change the color real quick. It goes here, and then now this node will do, say, n operations, right? Or n operations, just to do it. Well, okay. Well, the first time it'll do a depth first search, right? So now there's a regular depth first search. It goes right? I'm kind of lazy on this one, but you get the idea. But then now, let's say you have a second node. And then you do a depth first search from here. It goes here, okay, fine. But then now, in order to get a max, because now you're doing the actual memorizations on this edge and not this node, what happens is that now this node will go out and look again, right? Sure, every edge going out is cached, but it still does O of n cached lookups. So that's the hard part about this, is that, even though every node outgoing is cached, it still that takes O of n. And so that means that this will take O of n for this node. And that means that for this node will be O of n. And this node is n. This node is n. ... right? And then it takes, I mean, you're smart people at home. So that means that this will be n squared. And that's why it will time limit exceed. If you're not careful. I think I explained it in more detail in another problem. But hopefully that's enough visualization. And the way to solve this, keeping that in mind, is just to do two depth first search. I don't know why I took away the drawing, because I have to bring back the drawing anyway. The way that I did it is with two depth first search. Is basically, okay. So basically the first depth first search I do is just going to be, and this is, you could put it on anything. It doesn't really matter, right? Right. And so I do one depth first search, and then here the first depth first search allows me to calculate the max going up, right? So here maybe it's just some A, here it'll be some other numbers, I don't know, A sub 1, B sub 1, A sub 2, sorry, and ... right, going up. And this node will use, will keep track of all the children's best maxes, right? So that's all we have to do. And then the second depth first search, now given that, is just going to kind of go the other direction, right? So basically we break the problem into two parts. One is figuring out for each node, the max of all the children, right? And then now the second one is that now that we know the max of all the children, then now we're going to go get in with a max in that direction. And now that we're given the max in both the children and also going from the parent up, that's how we get the answer. And this is kind of tricky as well, because let's say we have here, right? And we're trying to pass in the answer here. Well, here, then now we keep track of all the answers like A1, A2, ... And then we pass in the max down here to go down, but we just have to make sure that if A1 comes from V1, or comes, that's my notations I have, we have to make sure that A1 doesn't come from this path, right? Because if A1 comes from the same child, then we want to pass it A2, the second best, because it has to be one of those two by pigeonhole, right? If you want the best, it's either the path that comes from the other children, or it has to be a path that comes from the other children, and the max out of the other children is either A1, which is the max of all the other children, or if A1 is from that children that you're recursing on, then it's A2, right? So that's basically the idea here, and it's a kind of hard problem, but yeah. Did I not have it up? I don't remember if I had it up. I don't remember if I have the drawing up, but this is the drawing I have, and hopefully that makes sense. The left diagram is just a tree and me drawing A1 and A2, and then the side on the right is just saying that for each node you need the max of all the children and max from the parent side. And that's basically how I calculate these things. I don't remember if I put it up, so yeah, if not, then apologies. And then the code will kind of basically go through it. Okay, yeah, so basically that's basically what I have. So yeah, let me see if I can get this so I could edit it. Sorry, hang on. Yeah, but basically here, so I highlighted, I created an edge list. This is pretty basic. I have a lookup table, and basically this is my first step for search, and this is to calculate the maxes from the children, right? So that's basically the idea. For each one, I do a recursion. I return the max of that child, and then for each node, I kind of did it just like lazy way, but you can get the max 2 elements. And basically that's what I do. I sort, and I probably should have just did like a max 2, but yeah, I sort, and then I take the first 2 elements and I put it in a cache, and then I just put yeah, and then I just return the max as either the max of the children, or if there's no children, then just the node, the price of the node. Yeah, and that's depth of search 1. So depth of search 2 now is pass in the parents max and calculate answer, right? That's basically the idea. I have a lot of print statements because I had to debug a lot for this one. I think the contest also just finished, so well, okay, fine. So I was curious how people actually did it. But yeah, but basically for each node, there's a lot of cases, but basically if this is just to show, this is just to kind of try to figure out what is the best path of the children. Like if the path is the children, we do certain things, and yeah, and having like, I guess I could put like a 0 on the next one to actually, that's what I should have done now that I think about it. Yeah, I think that would actually make the code a lot cleaner. Let's do that now. But basically I do this, and then maybe while length of max is less than 2, and then this would have made it like much easier, because then I don't have to do this thing. Because I think a lot of these things are just me checking it. If not, then if this fails, then you know it's my bad. Okay, well, the server's having issues, so okay, the server's having issues, but the idea is still the same, right? Like, I mean, we could go over the code, but this is actually much cleaner. I don't know why I didn't do it that way, but yeah, instead of writing all these if statements. But basically this is saying if the child is coming from that direction, I mean, don't take this code for granted because I haven't submitted yet because there's a service issue. But yeah, if this is coming from that child, then you know, calculate from the second best. Otherwise, take the best answer or the previous answer. Yeah, basically this is the max from the child of this node, and this is the max coming in, right? And basically what we're doing is passing this in as the what I call the previous, meaning from your parents' best, and then this updates the previous, meaning that okay, for this node we update the previous by either the previous or one of the children that isn't this child, and then we add it to the price of the node, and then we update the previous either this way or this way. And then other than that, the best, we just update the best. This is going to be re is just oh yeah, re is and this is always going to be true, so now, but I don't know why I didn't think of it that way during the contest. Well, I was trying to focus on the other stuff, but basically this is taking the max, so, and you could probably have taken this out, I suppose, but yeah, because they, you know, yeah, I actually this is really late in the problem to be doing this, but I actually skipped one part. So the maximum sum and the minimum sum for this problem, sorry, I kind of got lost in track a little bit, but the minimum sum for this problem is always just going to be one node, because the constraints are that everything is positive. So if you add more nodes, it can only make the minimum worse. So you only have one node, and then maximum is just maximum path in a rooted tree. So given this node as a root, what is the maximum path? Apologies for kind of saying that like 14 minutes in, because I was just so focused on the other part. But yeah, so in this this thing kind of shows it that much. This is the min price, and then this is the max price, and the max price is going to be max of one of his children, or coming in from the parent, and that's pretty much it. So this is actually linear time, linear space, because we only do two breadth first search. You could say maybe the sorting is going to make it n log n. You're probably right, but at worst it's n log n, because at worst this sorts everything in the edge, and there's only n nodes, right? So yeah, but if you if you don't do this stupidly like I am, this is linear, right? Because you can do some if statements to get 2, but yeah. So ideally, this is linear time, linear space. There are a couple of linear space things here, and lookup only contains 2 elements for each anyway. But linear time, because we look at each node in both the recursions. Cool. This is a way hard problem. Let me know what you think. Let me know what you have in the comments. And I suspect a lot of people got it wrong. I wish I could run this new code, but as you can see, the server's having issues, and I can't even look at things. So maybe my code's a little bit off. Let me show you my actual. Oh wait, did I click yes? No, this is not helpful. Okay, well, I can't even show you my actual code that I submitted because it doesn't even load. But this is going to be close to it. I mean, it's just more if statements. I think this should work. But if I'm wrong, then my apologies. And then you could just look at my code from the contest, or maybe from the beginning of the video. Cool. That's all I have for this one. Let me know what you think, and you could watch me serve a live in contest now. So maybe that's fine. Okay. I mean, this was a rough contest, but wow, people are really fast. Should have gotten that one though, the second one, but well. Difference between the maximum. Undirected, unrooted tree. Okay. So you have a tree. You have a price. On the ith node, the price sum is the sum of all prices of all nodes lying on that path. Okay. Root any root of your choice, then current choosing root is the difference between maximum and the minimum price of that root. Okay, it's 10 to the 5th, so you have to do some funky things. Is there any negative numbers? No negative number. So if there's no negative number, the min cost is always going to be the root. I think I messed it up last time, or like a similar problem. So in that case, what does that mean? What is the maximum cost? Oh, we want the max possible cost. So then that is just the longest path. Longest path in a tree. Well, maybe not. What's longest path for each one? People are getting it though, so yikes. People got Q3 really fast. Because I got it pretty okay, but I made a silly mistake. Can I TP this? It's another binary tree. For each node, then you have the max path for each thing anyway, right? I have to think about the star one. I think the star one always messes me up. But otherwise, actually, it's pretty easy. I always forget how to optimize that one. Oh, is it just another algorithm? Hmm. Hmm. I feel like I should know this one, but I don't know that I do. Because of the star graph. It's gonna be n squared. Hmm. Trying to think whether it makes sense to hack it. Can I think about it as just trees? If I think about just a node, it's just this node minus the max of the subtrees. And it going down. So let's say can I do the two for search? I guess that's the one. Let's see. No, because then now okay, I think we do two for search. Maybe that's why, but I don't know. So indexed. Right. And here we just return with a max, right? Basically, it's just only going up or down. So, okay. Okay, and then now basically pass in a number, right? Now what we want is it's not quite right anyway. I have to add in basically a node is price of the node is still going to be the min, and then the max is either TFS. It's going to be this or the previous minus this. I don't know if this is right, but it got the examples at least. Oh no. I'm really sloppy today though. I mean, let's see. So 0, 2, 0, 1, 1, 3, and this is 2, 3, 1, 1. X. That should be 6. But why did I get 5? Okay, so from 2, the answer is 2, which is maybe true. From 3, the answer is 5, but it should be from node 2. No, wait, this is the one. This one, node 2. I mean, node 2 or node 3, really. Should both be 6, right? 6 on the other one, 1 on the 3. But that doesn't matter. Right? 6 minus 1. Did I misunderstood this? Minimum price sum should. Did I drew this incorrectly? 1, 3, 2, 3, 1, 1. So if you take the 1, it's going to just be 6. Oh no, it includes itself. So it's 7. So the 1 is. The 6 is not right then. Wasn't this though? I should get this one quicker, but I'm just too silly on it. So 2 is the max is 6, which is true. Okay, but why is this 2? Max is going to be the lookup of node is 1. That's true, but the previous. Oh, the previous isn't coming in quite right because I messed up something. I missed a step on the intuition. This should come in, but how did I get that one right? But we should price in Oh, this part isn't right. It should be the max of everything that is in this node, right? So, and wow, a lot of people are so good. I know I'm doing it wrong. Is the short answer, but okay, fine. My sword, is that too slow? No, that's probably fine. Probably don't even need more than 2 elements, but remember to add in the price node later. Okay. But then now here, no, this is fine. We just return the first element, the bigger one. Okay. Okay, and then now, basically, we want to put in if this is equal to then you take the other ones. Don't know if this is quite right either. Guess it could be so elements. What am I doing? I have to do it for here too, yeah. If this is 0, then that's a leaf. So it's not the longest path anyway. No, that's not true. Wait, what? Jeez. This is just a mess the way that I'm doing it. Why am I doing it? Okay, that just got worse. 2. Where's my other print statement? Why do I print so weird things? Why do I print 3 twice? Do I mess up? No. I'm just so tired for this one, to be honest. Like, I feel like I'm close, but I'm not quite. Okay, so there's 0. We have 4 in one direction, 1 in the other. Okay, so then yeah. I know that's gonna do it, but okay, so that's 4, which is correct. I don't know why. Why are we doing the same node twice? Oh, I did do an elif. That's silly. Okay. So the 2 node does not have any children. That's true, but then passes in a 5, which is not true. Should pass in. Pass in the. Let's see what's passing the. So it's passing in the 4, which is not true. Do I miss something? All this has to be with the node. Oh wait, no, that's fine. This is just plus 2. Oh wait, no, that's not fine. I am really bad today. Okay, fix this one, but now the 40 is really wrong, obviously. How do you get 40? Pass it. So So on the 2, you pass in the 40, which is really off. No 2, so you pass in the 40, 10, 6, 8 is 24 at most. How do you get to 40? Passed in. What is the parent? Parent is 1, and 1 has a 17 passed in. That's not true. Well, 0. Okay, so the 0 has 24 is the best, but then now it passes in a 17. Why does it pass in a 17? Because it thinks that it is not its child, so that one of these things is wrong. So then that's 0, that's 24. Okay, so it thinks that 24 from 0. Okay. And then it tries to get the best from here, which is 16 plus 8. This should trigger. Okay, so it does trigger. Maybe. No, wait. It's trigger for 1. Okay. So it does trigger. But then now it does this thing, so previous. Did I misunderstand this one? So then it goes from 1 to 0. The previous is 0. And then price of the node is 9. So 9 would be the previous coming into 1. Except for it comes in as 17. Oh no, that's 17 with this. Yeah, okay, fine. Why did I put it that way? Okay, so 9, that's fair. But then now 33. How did I get 33 when it should be 24 on the previous? I think this is something's wrong here. So the previous is going to be 9. It shouldn't be in look. To go into 2, it is should be max. I'm just really bad today, I guess. 2426. Alright, let's see if I finally fixed it. The logic is fine. Well, I don't know, but I am definitely having a lot of issues with it. Come on, please. Okay. A lot of silliness. Like, I got the idea pretty early, but I just kind of really choked on the thing. Did I get wrong answer on this? Oh yeah. Yeah. I'm not as practiced, but it is what it is. I mean, but there's 10 minutes of penalty, so that's going to be a little bit painful. Whew. And I don't know if this includes China. People are really fast on Q3. I thought it was kind of, I mean, it wasn't easy, but kind of not hard. I mean, yeah, it wasn't easy. And Q4, I probably could have done a little bit better, but I was just kind of messing around too much. I wonder if you could just do it that way. I think this is the trap that a lot of people would fall into. And then something like fly in range of n. That I was really trying to not do, but I mean it'll be fast enough for these two, but they should time limit exceed it. But if it passes, I'll be very sad. That's not right though. I think there's a wrong answer for this one. That I because I would have gotten this in about 2 minutes, as you can kind of saw, but there isn't a there's a way to make this timeout, and I could kind of show. I'm not gonna write it in thingy, but for example, you can do something like s is equal to 10 to the 5th. Address is equal to fly in range of n. Address dot append. I don't know, what is it? 0i or something like that, right? And then this should time out. Oh, I forgot to do the price. It doesn't really matter, to be honest. Whatever. So this should time out. Okay, well. Okay, this should time out. Geez, what am I missing? Whatever. Right? Why is this keyword? What am I missing? Or like, why is this crapping out? Oh, it's price, not prices. Oops. So this should time out, right? And I suspect a lot of people will fail on this. That's why it took me a long time. Otherwise, I could have done this in about like 2 minutes, honestly. See, but this ACs, right? So we'll see what happens on this one. I mean, this is definitely getting challenged, and by me, if or whatever, because I definitely yeah, this is the right answer, and this is the wrong answer. Okay. Yeah. So a lot of people are going to get this wrong, I suspect, because that answer is very easy to write, and I would have gotten it in about 2 minutes, but I knew it was wrong. So, yeah, we'll see. We'll see if people are smart, because I took a long time to do it correctly. Was this the right answer one? Oh, no, this isn't the right one. I think I clicked on the wrong answer one. I was like, that looks too simple, because I did a lot of, not that one, the other one. Okay. Yeah, that's what I have for this one. That's what I have for this contest. I suspect I'm going up a little bit and then maybe going down a little bit, because I think it just doesn't update it. Or maybe it just doesn't include China, and my rank actually includes China. Can't tell anymore. Because I thought a couple of people, I mean, there are definitely a lot of Chinese flags, so I don't know how much it incorporates, because There's a eventual consistency thing, but yeah, and this is a very hard problem for Q3. Or Q4, sorry. Like, it's something that caught me a few times in the past. That's why I kind of took the long way. But yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about these problems and this problem and the explanation. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.